What is the mission of the Central Flight Control?
Well, this installation keeps track of the satellite after it's launched, including determining the first position, its first orbit, and extracting the information through the worldwide tracking system and reporting these results back to the experimenters who are desirous of knowing the effects that are happening to the satellite.
All right, let's take them one at a time. First of all, how do you keep track of the satellite?
As each satellite is launched, we're in direct contact with the launching facility, whether it's Cape Canaveral or elsewhere. As it's launched, our stations throughout the world are ready to track on the frequency of the satellite, and as soon as they receive the information, they extract the numerical data that tells its path in space.
Well, what kind of machinery do you use to do this tracking?
For tracking, we use non-moving antennas and use the mathematical relationships between the antennas and the motion of the satellite to determine its path. This is electronic, and these stations are very precisely located and very precisely designed. Their positions are known very accurately, therefore when the satellite goes by, we know where it went in relation to the Earth.
I see. All right, now let's talk about these stations a bit. You mentioned that there is a whole network of stations. Could you go a bit into detail? Where are they located?
We have stations, of course, in the U.S., and we also have stations in South America, 2 stations in Chile, 1 in Peru, 1 in Ecuador. We have a station just being completed in Newfoundland and Canada, 1 in England, 1 in South Africa, 1 in Australia. We have stations in the West Indies, and we have stations that cooperate with us, either through our own agencies or others in the South Pacific and the Pacific Islands.
Now, Mr. Huff, since the Mercury shot is forthcoming, will you be directly involved in this shot in any way?
Yes, the mission of the Central Flight Control Area will be to maintain a constant flow of data from the tracking stations to the computers, which are also located in this same building. And these computers will then tell us how well the man is in orbit and when he should make his certain rocket firings to bring himself back. This is a constant and a very rapid process that must be accomplished. The data must come in, we must determine where he is, tell him what to do, and send it back to the stations.
Mm-hmm. Now, Mr. Huff, I know that you have among your equipment, you are making use of the Minitrack system. Would you explain it for our audience? What exactly is Minitrack?
A Minitrack is a device that uses the technical name of phase interferometry. Basically what it means is we have 2 antennas spaced apart from each other. The signal naturally arrives at one antenna sooner than the other. We can determine the difference in arrival of a signal from a satellite at one of these 2 antennas. If we place them east and west, we can tell its motion relative to east-west motion. We also have another pair north and south. From this information, we can develop the angles that would be measured if you could see the satellite with your eyes to the object and thereby determine its path relative to that spot on the Earth.
Well, but Mr. Huff, there is one thing which I fail to understand. From the moment the satellite is shot from the ground until it goes on the air, is there a radio which keeps you informed of its movements at all times?
Oh yes, each satellite has in it 1 or usually more transmitting radios. These radios, one is designated as a tracking radio, and it's this one that we listen to with our Minitrack to determine where it is, how fast it's going, how high it is, and which way it's going to continue going. The others are used to send back the information in coded forms concerning the different phenomena we're investigating, such as the density, the temperature, the radiation that's in the Van Allen belt, for instance. Each experiment is sent back by a separate group of transmitters called telemetry transmitters.
In other words, you also keep track of this information too?
Yes. At the same time we're tracking, we have another system of electronics at the same station that, as we say, extracts or pulls out this information from the other transmitters. At times, we have the satellite store up information as it goes around on tape and wire recorders, and then at the very same station that we are tracking, we command with a small transmitter the satellite to broadcast back to us what it has learned in the previous revolution around the Earth.
Now, Mr. Huff, is the central flight control at Goddard similar to all the other, I should say, central flight controls in the other stations around the world, or is there anything different about it?
Now, this is the heart of the network. And you can imagine each station as a sensor, such as an eye or an ear on the human body. Each one feels something and extracts or reads information. It's connected by a communications nerve system to the heart, which is the central flight control. This information feeds in from all stations to this one point. Here, all of it is used to determine the precise position and path of the satellite in space. Here, all of the information that has been measured by the satellite is correlated and given to the experimenters, who then can evaluate it and find out what the outer space is like, such as Mr. Van Allen discovering the shape and size of the radiation belt which his satellite helped discover. So this is actually the heart of the system. The mini-track and tracking stations are the nerves, and they are connected by nerve fibers back here. In addition, the heart sends back information, much as a bloodstream, to them, telling them when to expect the satellite next, its precise frequency so they can receive it well, and what type of information is coming out of it so that they know that they're receiving properly. This is a continuing process. At present, we have about 12 satellites that we're doing this to, and there will be many more in the next year.
Now, Mr. Huff, one last question. Do you feel that the present system of monitoring satellites in space is adequate, or do you expect improvements?
In regards to telemetry, that is the extraction of information as to the atmosphere, if we could use the word, there is no atmosphere there, but the environment that the satellite is in and what effects it's undergoing, this will be constantly improved. We will find out what type of environment it goes through, how much heat, how much pressure, how much radiation, and necessarily improve our equipment both in the satellite and on the ground to gain more information and better information in the sense of having it in a better form. The tracking system works very well and can only be improved for sensitivity, that is, for reaching out further. We will also, of course, take it up to different frequencies which will give us much more precise information. At present, we can tell where any satellite is within about 15 seconds of angular arc from the ground. We feel certain we can improve this to less than 1 second of arc by going to higher frequencies than we are using today. This approaches optical precision with radio frequencies.
Thank you, Mr. Huff. We have been speaking with Mr. Harold Huff of the Central Flight Control at Goddard Space Flight Center. This is Michael Hanno.